This is a continuation video. We are going to look at matrix operations. So in this video we are looking at matrix operations. So matrix operations. So when we talk about matrix operations, we are talking about the transpose of matrices. Then we're talking about sum and difference of matrices. Then we are also talking about multiplication by a scalar, so scalar multiplication of matrices. Then finally we are talking about multiplication of matrices. Then not also forgetting about inverse of matrices. Inverse of matrices. So the inverse of matrices is also what is going to bring about simultaneous equations. Remember, all that is above, we are going to look at a 2 by 2 matrix, 2 by 2 matrices. So we are just going to rely on 2 by 2 matrices. I know there is 3 by 3, 4 by 4, but in this video we are going to look at 2 by 2 matrices. So the matrix operation and the transpose of matrices. So if you've got a matrix A, which is can give an example of anything that. So if this is a matrix A, so notice the number of rows. The rows, remember in our previous video we said these are rows and these are columns. So to transpose a matrix is simply to write the rows as columns and columns as rows. So if a matrix A is transposed, it will be represented by A capital T or A T. So that is the transpose of a matrix. So if you look at that matrix A, if we want to write its transpose, so if we want to write the transpose of A, we are going to say this one which is going like this, let it go down. And the second one, second row, will become the second column. So we have this number we have 3 and 0. So that 3 and 0, it was a first row. So let it become a first column. So we're going to have 3 and 0. 3 and 0. Then the second column is 4, negative 1. It was, second row. Then let it become the second column, which is going to be 4, negative 4. Like that. So that is a transpose. So the other concept is that if you transpose a matrix, again you transpose it, it gives you back the original matrix. For instance, you can notice that we have transposed this matrix to this one. So if we want to transpose this matrix again, the transpose, if we opt to transpose it, we are going to say this row will be written as a column, and this row will be written as a column. So you can see that transposing a transposed matrix gets you back to the original matrix. So that's what happens if you transpose a transpose matrix. It simply means you are getting back the original matrix. Okay, after being done with the transpose of a matrix, we are now going for sum and difference of matrices. Sum and difference of matrices. So sum and difference of matrices. So two matrices A and B can only be added or subtracted if they are of the same order only in that case. So two matrices A and B can only be added or subtracted if they are of the same order. So that is how you can add or subtract two matrices. Okay, just a quick revision. Order. So the order of this matrix, suppose we've got matrix. What is the order of this matrix? You say row by column. So if you look at the number of rows, we have got 1, 2. So this is 2 by columns 1, 2. So this is a 2 by 2 matrix. If you have got another matrix, 0, 3, 4, 0. If you have got such a matrix, the order is also 2 by 2. Why? Because you're seeing 1, 2 rows, 1, 2 columns. So this matrix and this matrix, they can be added or subtracted. Why? Because the order is the same. Okay, sum and difference of matrices. So suppose they ask us to say evaluate the following. So if A equals and B equals then we have been asked in the first question to say A plus B. So we know it's a 2 by 2. So we're going to get the first matrix, which is A, and then put the operation symbol, which is a plus, and then get that one. From there, to add a matrix, we are going to combine 3 and the corresponding entry 0, -1 and the corresponding entry 2, 4 and -1, 2 and 4, just like that. So 3, suppose you lift this matrix and place it on this one, on which number will 3 be? It will be on a 0. So there is a plus and 0. Then 4, there is a plus, but because of the minus, we are going to get a minus. Then we go for -1 plus 2. 2 plus 4. So 3 plus 0, we get a 3. 4 minus 1, we get 3. -1 plus 2, we get 1. 2 plus 2, we get, 2 plus 4, we get 6. So that is our answer. Okay, from the same question 2, they ask us to say B minus A. So for B minus A, we'll start with B, which is 0, -1, 2, and 4. Then there's a minus here. Then the matrix which we have there for A is 3, 4, -1, 2. So In the same manner as we do for addition, we get the corresponding entry. The one which is number 1 here will combine with the one which is number 1. The one which is like that, just like that. Suppose you lift this matrix, on which number is it going to place? That's the number you combine with. But be mindful of the sign you are using. So here we have got a 0. The one which is opposite to this one is a 3. But there is a minus here, so we say minus 3. We go for 2. We get 2 minus. If the minus are 2, we always put a plus now and the number. But if there is only one minus as you combine, then you maintain the minus. We go for 4 minus 4. Oh, sorry. Negative 1 minus 4. Negative 1 minus 4. Then this 4 minus the 2 there. The 4 minus the 2. So I'm saying 0 minus 3. This is what we have here. 2 minus negative 1. Since the negatives are 2 now, if you multiply negative and negative, you get a plus. So we have 1. Negative 1 minus 4. Negative 1 here minus 4. 4 here minus 2. 4 here minus 2. We are now having 0, remove nothing, we'll just remain with a negative. Negative and negative, we combine and maintain the sign. So that is the rule. It's like you are on negative 1, and again you move to the negative 4 times. So you will still be on the negative side, but on the 5th position. So 2 plus 1, it's clear here, it's just a 3. Then 4 minus 2, it is a clear 2. So this is our answer. So addition and plus and minus, they are just the same, only that here you subtract, there you add. Otherwise, how to operate it is just the same idea, but just different signs.